हेलो दोस्तों। हाँ, तो आज हम लोग करने वाले हैं बिटसेट के कुछ क्वेश्चंस। ये क्वेश्चंस नॉर्मली बिटसेट में एक्सपेक्टेड क्वेश्चंस हैं, ना ज़्यादा हार्ड ना ज़्यादा इजी, वैसे वाले। तो चलिए शुरू करते हैं। ये क्वेश्चंस मैंने भी बना नहीं रखे हैं, तो मैं आपके साथ ही बनाऊंगा। तो let's see. So the first question says that the coordinate of moving particle at any time t are given by x is equals to a t alpha t cube and y is equals to beta t cube and the speed of the particle. So x is equals to alpha t cube and y is equals to beta t cube. Then vx is dx by dt, that means the speed around x direction, which is equals to alpha t square into 3, and vy is equals to dy on dt, which is 3 beta t square. Okay, now if we say, then the v net is vx square plus vy square, the whole square root, is equals to 3 square, then 3 will be out, and then alpha square, beta square, t square and t square, then t square will be out also, and the alpha square plus beta square. This will be answer, which is option number D. Let's move on to the second question. First read it, which is the power P, surface tension T and Planck's constant H are arranged so that the dimension of time in their dimensional formulas are in ascending order. Then which of the following is true? So we have to simply find the dimensional formula of power, surface tension and Planck's constant first. So power is energy upon time. So for power, it's ml t minus 2 into L, which is force into length. We can say that the dimensional formula of energy and work is equal. So we are going from that way, and then time is t. So this is going to be power is directly proportional to t minus 3. Okay, we found out this. Then we move on to surface tension. Then surface tension is equals to force upon length. So therefore, for surface tension, it will be like this. So surface tension is directly proportional to T minus 2. Okay. So surface tension is equal to T minus 2. Now we will move further to Planck's constant. So Planck's constant. So the Planck's constant H is equals to energy upon mu, which is frequency. So it will be mlt minus 2 into L by 1 upon T. Therefore, H, Planck's constant, is directly proportional to T minus 1, I would say. So now we have found out all three. So now we have to compare it in ascending order. So in ascending order, if we arrange them, it will be, we can say that 1 upon T cube is less than 1 upon T square less than 1 upon T. So therefore, we can say that power is here, then surface tension, and then H. So when we match it with the option, it will be power, tension, and H. Power, tension, and H, which is option number A. Which is option number A. Now let's read the next question. So the third question states that the girl ran at speed of 4 meter per second to overtake a standing bus when she is 6 meter behind the door at t is equals to 0. The bus moves to forward and continues with an acceleration of 1.2 meter per second. The girl reaches the door in time t when. So let's make a rough diagram that maybe this is runs at a speed. So this will maybe the girl. Okay, and she runs at 4 meter per second to overtake a standing bus. When she is 6 meter behind the door at t, so the bus moves forward, and then at this is t is equals to 0. Then the bus moves forward, continues with an acceleration of 1.2 meters per second. Okay, so let's say, okay, so let's say that girl reaches the door after tea time. So to cover, let's s distance, we can say for bus s is equals to half a t square. For girl, s plus 6 is equals to 4 minus half a t square. Sorry, it will be like this, 4 into t. Okay, so now we can state that from this 1 and 2, we can say 4t is equals to 6 plus half a t square. Now let's match it with any option. Let's, it will be equal to this option. Okay, it will be option A. This is option A, as when we put a is equals to 1.2 and 1.2 by 2 is equals to zero point 0.6. Now let's read the another question. So question number 4 states that the mass m is attached to the end of a rod of length L. The mass goes along the vertical circular path with other and hinged at its center. What should be the minimum velocity of the mass of the bottom of circle so the mass completely completes the circle? See, we can solve this question with energy conservation. Energy conservation. Okay. But this question is also a very popular case and we should remember this, that any vertical with the end, what should be the minimum of mass at the bottom? So we can, it's a popular case and it should be remembered. It should be remembered that, let's say, when there is a hinge, let's make a circle first. Okay, so let's say when a bob is stacked around this, to complete this circle we have to throw it with under root 5 gl, or not this. So the case is that on the top of this circular path it should be going with the speed of under root gl. Now if this is a popular case and it should be remembered, so the answer of this question is simply under root 5 gl. So question number 7 is, which of the following is not an example of perfectly inelastic collision? So perfectly not an inelastic collision. Question, option A is an inelastic collision, as the bullet fired into the block, the bullets get embedded in the block. So if a bullet is embedded in a block, it's an inelastic collision. Capture of an electron by an atom, it is also an inelastic collision. A man jumping into a moving boat, option number C, is also an inelastic collision. But the ball bearing striking another ball bearing, as we can see, like it is like this, like, and let's see, mm, like this, and we have small ball bearings here. If one ball bearing hits another, this one stops and this one will move forward and it will hit the third one. So it is not inelastic collision, as momentum is conserved. So the option will be D here, which will be correct. Okay, now let's move on to question number 8. So question number 8 states that, consider a uniform square plate of side A mass m and the moment of inertia of this plate about an axis perpendicular to its plane and passing through one of its corners. So let's make a plate first. Let's make a plate. Maybe see, this is an plate. Okay, and This is the point. Should go perpendicular, and we have to find it through one corner. Maybe this is the corner. This will be a by 2, and this will be a by 2. So this will be a by 2 root 2. Okay. Then the I axis we want is ICOM plus M a root 2 whole square, which is MA by 2 plus ICOM. Okay. Now let's find ICOM. ICOM here will be MA square by 6 plus MA square by 2. MA square by 6 is the ICOM, the moment of inertia of the square block, we can say. So for that, if it would be a rectangle, if it would be a rectangle with side A, with side A and B, it would be have a m square plus b square by 12. But for the square, it will be ma square by 6. So it will be 6 ma square plus 3 ma square, which is 4 ma square, which is eventually will be 2 by 3 ma square, which will be equal to option number 4. Option number 4. Let's move on to the next question, which is question number 9. Okay, question number 9. Question number 9 states that a biometric consists of metal X and Y. It is mounted rigidly at the base, as shown in the figure. The metal X has a higher concentration or coefficient of expansion as compared to metal Y. When the biometric spit is placed on the in a cold bath, when the biometric strip is placed in a cold bath, okay, this cold bath is important. Okay, so as the okay, so for the cold bath, it's a cold bath, the metals will shrink, the metals will shrink. Okay, and the alpha x is greater than alpha y, then the lx will be less than ly. So it will eventually be like this. First, let's move this. It will be eventually look like this is getting shorter, and this will be a bit bigger, which will eventually turns like this. This will be x and this will be y. So it will bend towards left, which is option number A. It will bend toward left, option number A. Now question number 10. The excess pressure inside one soap bubble is 3 times that inside a second bubble, when the ratio of their surface area is. Okay, the excess pressure inside one soap bubble is 3 times. So we know that, let's first remove this. The formula for excess pressure for a soap bubble is 4SR. Okay, is 3 times inside of second. We are assuming that the radius of the soap, both the soap bubbles are same. Okay, and then we are saying that 3p1 is equals to p2. Okay, then the ratio of their surface area. Okay, we have to find the surface area. The surface tension is constant here. This is constant. We have to find the radius. Okay, so we will be like 3 into 4s r1 is equals to 4s r2. So 3r2 is equals to r1. 3 times of r2 is equals to r1. Therefore, let's see, surface area is face area is equals to 4 pi r square. So surface 1 is equals to 4 pi r1 square, and surface 2 is equals to 4 pi r2 square, as r1 is 3 times of r2. So s1 upon s2 is equals to 9 is to 1, which is equals to s1 is 9 times of s2. Let's match it, is 1 is to 9, although the option number D is correct. Question number 10. Let's move on to the next question, which is wait a minute. It will be option number A here, not option number D. Yeah. Let's move on to question number 11, which is two equal drops are falling through air with terminal velocity 5 centimeter. The drops get combined, the new terminal velocity will be. Okay, let's delete all of this first. Yeah. Hmm. So the terminal velocity for each drop is 5 centimeter per second. So when two drops will be mixed, let one drop is of radius r, and when two drops will be added, the radius, let's say, will be r. So 4 by 3 pi r cube into 2 is equals to 4 by 3 pi r cube. So 2r cube is equals to r cube. Okay, and now we know that the velocity, terminal velocity, is directly proportional to radius square. So 5 is directly proportional to r square. So v dash is directly proportional to r square. Okay, so let's find out that first. So if we can say that 5 upon v dash is equals to r square upon r small r square, and from here we can say that from this relation we can say is 2r cube to power 1 by 3 is r. So we can use this here. It's 5 upon v dash is equals to r square into 2r cube 2 by 3. Okay, so it will be cut, and v dash will be equal to 5 into 2 to the power 2 by 3. Okay, which will be equal to 5 into 4 to the power 1 by 3. Let's see which option. Okay, this is option number C. Option number C is correct for this one. Okay, now let's move on to the question number 12. So question number 12 states that the wire of length L and cross section area A is made of material of Young modulus Y. If the wire is stretched by amount X, the work done is. So let's see that gamma is equals to F upon A delta L upon L. So here delta L is equals to X. So first of all, F is equals to gamma A X by L. Now we have to find work done. So work done is equals to half. We can use the work done formula as half kx square, where the k is gamma A upon L. So which will be equals to 1 by 2 gamma A L x square. So let's see it in the options, which is this option number B is correct. Let's move on to question number 13. Question number 13. The lead bullet of initial material 27 degree and speed of v penetrates into the solid object and melts. If 50% of the kinetic energy is used to heat it, the value of v in kilometer hour is. Okay, the lead bullet of at speed v kilometer penetrates into a solid object and melts. 50%. Okay, so the melting point of lead is 600 kilometer. Let's see what we can do. So the T1 temperature where it is 27 degree, which is 300 Kelvin. Okay, the final temperature it will be having is 600 Kelvin. Latent heat of fusion is 2.5 into 10 to the power 5, and specific heat is okay. So the Q will be ms delta T plus ml. So ms delta T, which is 300 into 125 plus L, which is 2.5 into 10 to the power 4. This is 50% of the, this is 1 by 4th of mv square. We can say it like this. So m and m is cut. We have v square is equals to 4 times 3 is like 38000. No, it will be not like this. Okay, it will be 375. Yeah, 37500 plus 25000. Yeah. So now add this. We will get 4005216250. Okay. Now V square. So V will be equals to 2 into 25 into 100, which is equals to 50, this 5000. Okay. Yeah. It's not matching. Okay. Kg and kg. Everything is correct. Then what's the problem? 25 625. It's correct. Okay. All of it is correct. My answer is 5000. I want you guys to check this question. A lead bullet penetrates into solid V into 10. It will be, so it will be 500. 500. Okay. 25 into 4 into 2. Okay. Will be